So work with me on this one. Angle D would have to be congruent to what other angle? So think about the corresponding parts. So Courtney, what would angle D be congruent to? Okay, now since we're not really clear which side is H, we would need J, H. All right, Sam, angle Y is congruent to
DRT.
DRT. And then this is probably a really important skill to have here, and it's learning how to line up the corresponding parts. So we have the ratio of JD to JH is equal to, now look at what we're doing there. What we're doing is JD, so the whole length of JD, compared to the length of JH. So what would that be equal to? What would be another ratio where that would be equal? Let's remember that if two shapes are similar, then their corresponding sides must be proportional.
So would you be able to say RT over YX? Like, is that what
Yeah, that would be perfect. RT over YX. Now notice how this was set up. JD is the bigger trapezoid. So that's the big over the small. So it'd have to equal the big one over the small one. Is there another ratio I could have used?
DR and HY.
I've done DR, HY. I could have also used JT and JX. So lots of options here. But again, the most important piece is making sure you have the corresponding parts aligned. All right, take a look at number 4. I have YX over RT is equal to blank over DR. Caitlin, what do you think?
HY.
That'd be HY, yeah. Okay, so we getting this down where we're looking at the corresponding parts?
Yeah.
All you do is get them lined up. So now we have to decide, are they similar? Now, remember the first thing, let's go back to the first page. If they are similar, then they have congruent angles and proportional sides. All right. So we look at this page here. And we look at number 1, and I have 2 rectangles. All 4 angles are right angles. So do I have congruent angles?
Yes.
Okay, that's probably the most obvious one you should look for. Because if you don't have congruent angles, it's automatically not congruent, or not similar. So they have to have congruent angles. So that's good. Now we have to look at corresponding sides. And we have to make sure that the ratio of the corresponding sides is the same. So so if we look up here, we have DC. How long is DC?
Is it? I can't.
36? Yeah, that's really faint. We'll zoom in on that. Maybe. Yep, 36. Okay, so we know that DC. So, okay, let's do this. We should have the ratio of DC to what?
HG.
HG. And that should be the same as BC to FG. So we said DC was 36. How long is HG? BC is 20. FG is 30. Okay, what is 20 over 30 reduced down to?
2 over 3.
2 over 3. Notice I'll put a little question mark here, because we're not really sure if they are equal. All right, 36 and 52. Is there something that divides evenly into both of those?
2.
4. Yeah, 2 and 4 both go. Let's go with the largest. So if we divide it by 4, we have 9 over 13. Is 9 13 equal to 2/3? So are my rectangles similar? Nope. Not similar. We look at number 2. Are my corresponding angles congruent? Yeah, okay, so that's the first check. Now we have to go to make sure the corresponding sides are congruent. Or not congruent, sorry, but are proportional. So let's zoom in here on QRST. Okay, we have ST is 6, QT is 7.5. Now, here's another way you could do this. You could write this up actually as a ratio within the shape itself. If I take the ratio of ST over QT, that would equal, now notice what I did here, I did ST over QT. What would that correspond to?
Wouldn't. Okay, that would be ZY to YX.
ZY, not YX. Oh yes, you're right. That'll work. Okay. So we look at this. We say, okay, well, what is ST? ST is 6, QT is 7.5, is equal to 8 over, well, we don't really know what YX is, do we? So in this particular case, we can't really tell if it's similar or not. I mean, you don't really have enough information. Mostly because I screwed up the diagram. I think I was trying to put 16 up here. So that doesn't even make sense. Let's ignore that. Not similar. There we go. That's the judgment. Okay. Now, when we do a similarity statement, just like when we do a congruent statement, corresponding parts must align. So if I want to say that triangle ABC is similar to, okay, now here we go. What is ABC? What does A correspond to?
FEB.
F, E, and then B. All right, any questions on that?